Okay. So electric field, equal and opposite electric field. So what is the net electric field? It will be 0, right? Yeah. So it is not this one, it will become 0. So be careful when you do this. That's it. Similarly, for negative charge also, you can just do it in the same way. If you calculate electric field will be what? For this, it will be EB, and for this, it will be EA, because you are keeping a positive charge here. Equal and opposite electric field. So electric field at the midpoint will be 0, whereas the potential will not be equal to 0. Potential, if you calculate, you will get minus K2 KQ by R you will get, because it is minus sign. So negative for negative charge, positive to positive charge. So what we can conclude? Okay, the potential at the, okay, in case of two equal and in case of two equal and same charges means same nature charge, okay? Two equal charges of same nature, in that way it sounds good. Two equal charges of same nature. What will happen at midpoint? Potential will not be equal to 0, whereas electric field intensity will be 0. It is a vector. Clear, no? Everyone?
Yes, ma'am.
Good. So next one is positive and negative charge which are at a distance 2r, and the P is at midpoint. Now if I have to find out the electric field and the electric potential, first we will calculate electric field. Electric field, if you calculate, you have to place on unit positive charge. So what will happen? This will repel. So EA will be this way, and EP will also be in this way only. What is the reason? It is attractive. So the net electric field will not be 0. What will happen to the electric potential? Calculate and tell me. The electric potential at point P will be due to plus Q and plus minus Q, both the charges. So due to the positive charge, it will be KQ by R. Due to the negative charge, it will be minus KQ by R, because it is a negative charge. So potential at this point will be 0. So in case of two equal charges of opposite nature, what will happen at midpoint? The electric potential will be 0, but electric field will not be 0. Clear, ma?
Yes, ma'am.
Good. So now,
Ma'am, can you please pull up?
yeah, sure.
I need to write down this. You need to find it out. Summation only, scalar, so it is very easy. At the point P, centimeter. So now we have three charges, okay? Three charges, let us take 2 centimeter, 2 centimeter, 2 centimeter only. So how will you find it out? Due to all these three charges, you need to find it out. Summation only, scalar, so it is very easy. At the point P is nothing but what? V due to 2 microcoulomb, and then V due to, what you can write, this is 1, you can take it as 1, 2, 3. So V1 plus V2 plus V3. So what is V1, ma? It is nothing but K Q1 by R1, then K Q2 by R2 plus K Q3 by R3. The only thing you should remember is with the sign you need to consider. So here K is constant, so I can take it outside. Q1 is what? 2 micro divided by what is the distance? It is 2 into 10 to the power minus 2. Plus Q2 is what? Minus 2 into 10 to the power minus 6 divided by 2 into 10 to the power minus 2. Plus Here R is also constant. You could have taken it out, but it's okay. So 3 microcoulomb divided by 2 into 10 to the power minus 2. So if you want, you can take this R value outside. Okay, it is common denominator. So 2, this one and this one will cancel out, right? 2 minus 2 plus 3 will be in the numerator. So 2 will cancel out. So Vp will be equal to 9 into 3 into 10 to the power 9 divided by 2 into 10 to the power minus 2. So it is nothing but 27 by 2 into 10 to the power 11 volt. It is quite high. So I have given random numbers. It has come. So you need to find the electric potential at the point P. That is the center of the cube. Okay, what it will be? You need to find out the distance from the vertex, right? From each vertex, you need to find out the distance, but it will be equidistance, right? So it is nothing but what? What is the diagonal value of the cube from all the directions? So root 3L, right, is body diagonal. Along the body diagonal, this one is at the center. Can you imagine? In the square box, this point P is at the center of the cube. So this charge R will be, that is, sorry, this Q from the vertex, you have to connect it in this way to the point. This lies along the body diagonal. What is the body diagonal of the cube? It is given by the formula root 3L, right? It is half of body diagonal, right? That is nothing but R we have taken. That value is what? Root 3 by L. 2L. Yeah. Now what is the potential at the point B? You find due to one charge, then the rest of the things, totally 8 charges are there. You can simply multiply it. Okay, so Vp due to one charge, if you take it, what it will be? K Q by R. What is the value? K into Q is Q only. Root 3 by 2 into L. So what value it will be? KQL divided by 2 KQL by root 3. This is potential due to one single charge at the center. Now if you want to calculate it for what? 8 charges. It will be due to 8 charges, right? Algebraic sum. So you can just write 8 into 2 times KQL by root 3. That is nothing but 16 KQL by root 3. Clear or no? If it is not clear, let me know. Because body diagonal distance only. The phase diagonal you are not calculating. This is phase diagonal. Phase diagonal, if they ask you square diagonal formula, you have to use 2L. Here what we are doing, from one corner to the opposite corner we are joining. That time body diagonal formula you have to use. Clear now everyone? That means tell
yes,
me. Good. So this is one kind of sum. Okay, here the potential won't be 0. Electric field, of course, if you take a symmetric figure, if you keep equal charges at the vertices, what will happen? The electric field will be equal to 0. Is it clear or no? Any doubt?
Ma'am.
And the body, the phase diagonal, easily you know, it is Pythagoras theorem. Okay, this is, in this diagram, they have taken D, right? I have taken it as L. So you can change it to L also. Let me do this. Is L, this is L. So according to the Pythagoras theorem, what it is? Square root of L square plus L square is this side, right? Let me do it.
Yes, ma'am.
So L square plus L square, that will give you root 2L, correct? This is?
Yes, ma'am.
Phase diagonal. Body diagonal calculation, similarly you have to calculate it. When you calculate it, you will get root 3L. It will be slightly tricky because here from this to this distance you need to find out. So what is this distance? This is L, right? This one. And what is this distance?
It is
root
root 2.
2L.
Then you have to find it. Apply this, okay? Pythagoras theorem. So this diagonal will be what? L square plus root 2L the whole square. That is nothing but L square plus 2L square, right? So it is
Yes, ma'am.
3L square.
No, I understood it.
Is placed at 1, 0, 0. If you take M as 1, you can do it in that way. The Q1 is placed along x-axis. 1, 0, 0 means what? Y is 0, x, Z is 0. Only x value is there. So if you draw it in the Cartesian system, it will be like this. So this is where you are having Q1 charge. So this is 1, 0, 0. Next one is what? Q2. Q2 is in 0, 2, 0. That means on the y-axis, it is placed Q2. 0, 2, 0. And the third one is along the z-axis. So here, 0, 0. You need not draw the diagram. It is not necessary. Just for understanding the placement, I have shown. Okay, so this is minus 2 microcoulomb. This is 1 microcoulomb. All you need to find out is electric potential at the point origin. Okay, so the distance is clearly given here. The distance is 1. Here the distance is 3. Here the distance is 2. So at O, what is the potential? It will be due to 1, 2, 3, right? Just so it is nothing but K Q1 by R1 plus K Q2 by R2 plus K Q3 by R3. So what is the value of K? K is constant. So I am taking it outside. Q1 value, what they have given? 1 microcoulomb divided by what is the distance? 1. Plus Q2 is what? Minus 2 divided by what is the distance? 2. Then plus Q3 is what? 3 by 3. So this becomes 1. This becomes 1. So what will happen? 1 minus 1 plus 1. So you will get only K into 1. That is nothing but 9 into 10 to the power 9 volt or joule per coulomb. Clear?
Yes, ma'am. It's cool.
This one of the system, this is what you will write. And potentially, what is the electric potential energy, ma? Electric potential at this point. If they ask you what you will write, U will be equal to K Q Q by R. This is what you will write, right? Electric potential energy is given by Q times V. So no. So what is the electric potential energy of the system? This is what you will write. And potential is given by work done in bringing a unit positive charge from infinity to that point. Now it is tell me, what is the system of charges? It is nothing but electric potential energy is nothing but what? Work done in assembling the system. One charge means you will straight away write it is the work done in bringing the charge from infinity to that point. But here what we are? Assembling the system of charges. So now listen carefully. You are having a charge Q1, Q2 at infinity. Both the charges are at infinity. Now you want to bring this charge Q1 from free space and you want to keep it at A. Now, Ishan, tell me what will be the work done in bringing the charge Q1 to this point A?
Charge.
This charge from
Ma'am, it will be 0, ma'am.
Why? Okay, your answer is right. Work done will be 0. Work done is 0 because what is electric potential or electric potential energy definition? Work done in bringing a charge from infinity to that point against the electrostatic force. Is there an electrostatic force at this point A? No electrostatic force. It is a free space. So you need not do any work in bringing the charge from infinity to that point A. Clear, ma'am? Since it is an empty space, you are not doing work against anything. When we do some work against the electrostatic force, that work is stored as potential energy. Here there is no electrostatic force, so no work is required to be done. So what is the work done in bringing the charge Q1 from infinity to that point A? It will be 0.
and you have placed successfully the point Q1 here. Isha? Okay, Isha is. Now, try to bring the charge Q2. Now, as soon as this charge Q1 enters into this free space, it is no longer a free space now. This charge Q1 will started ruling this space. It will just define its own territory and it will extend its electric field intensity up to infinity. So if you consider the point B, what will be the potential at the point B due to this charge? Let us take that potential as VB. Okay. What will be the potential at B due to this charge Q1? If it is at a distance, let us take
Q1 by R.
Very good. K Q1 by R. So you got it? This will be the potential due to the charge Q1 because now it has come to the place A. It starts ruling, so it will have its own electric field and potential will be there at each and every point. Now what you are doing, you are trying to bring Q2 to this point B. This Q2 should not move. It should be at B. That is what I wanted to do. Okay. So you are trying to bring the charge Q2. Now will there be an electrostatic force of repulsion? Because or electrostatic force of attraction. I don't know about nature of the charge Q2. So Q2 may get repelled or attracted towards Q1. But there will be an electrostatic force, right? Because already Q1 is there. So we have to do work against this electrostatic force. So what is the work done? How will you do that?
Ma'am, K Q1 Q2 by R.
Very good. K Q1 Q2 by R, right? Why? What is the reason? Work done is given by what? Potential at point P is nothing but work done in bringing the charge, right? We know, is it not clear, ma?
No, ma'am. Clear, ma'am.
Yeah. See what happens again, the same derivation, whatever we have seen in the previous case, electric potential due to. See, there we have taken positive Q, capital Q as the source charge. Here now, what is the source charge here? Small Q1. So you are bringing the charge Q2 from infinity. So what you are doing this infinity at point, intermediate point P, what will happen? It will start experiencing an electrostatic force. You have to do work against this force. So F external you will apply. So this F external must be equal and opposite to the electric force. Right? So what is the electric force? Electric force is given by what? How much? You are bringing the charge Q2. Right? And what is the work done? Small work done is nothing but Fe minus, initially what you will write? F external, work done by the external force is equal to F external and you are moving through a small distance, dx, right? F dx. So when we want to calculate the entire work done in bringing the charge from infinity to the point B, that is at a distance r. So F external into dx. What is F external, ma? F external is equal and opposite to the electric force. So minus Fe into dx. What is Fe? If I consider the charge is at a distance x, the point P is at a distance x. So infinity to r minus k q. What is force? Electrostatic force. What is electrostatic force? Q1, Q2, Coulomb's force. What is the electrostatic force of repulsion here? It will be equal to K Q1, Q2 by R square, right? X square. So the same thing you do it here. So K, Q1, Q2, everything is constant. I am taking it outside. 1 by X square, D square. Here we know now.
Yeah, ma'am.
So now work done will be equal to minus K Q1 Q2 on integrating 1 by X square. What you will get? Minus 1 by X infinity to R. We have done this 2 times in our previous classes. So substituting this limit, minus minus will become plus 1 by R. That is 1 by X. You have to substitute upper limit minus lower limit. 1 by infinity is 0. So what it will be? K Q1 Q2 by R will be the work done. So
So this work done will
Yeah,
be
ma'am.
stored as potential energy at this point charge Q. Clear or no? So work done is nothing but what? W2 is what? K Q1 Q2 by R. So total work done is what? Total work done will be equal to W equal to W1 plus W2. That is 0 plus K Q1 Q2 by R. So that is nothing but K Q1 Q2 by R. So what is this? Work done is stored as what? Potential energy. So electrostatic potential energy can be defined as of a system of two charges. Is equal to what? Of a system of two charges Q1 and Q2 separated by a distance R. This is the system. The distance should not change, okay, for this system. Distance R is nothing but what? It is equal to what? Work done in assembling these charges from infinity to a distance or between them. Wherever you want, you assemble them. But the distance should be R. Yeah. This is one way of explaining. The other way of explaining is direct. Okay. Consider this charge Q1, work done will be equal to 0. Okay. Because of this, there will be a electric potential at this point B. So VB is given by KQ1 by R. Now what we know, we have to bring a charge Q2 from infinity to this point. What is the formula for work done? We know VB is nothing but what? W by Q. Right? This Q is nothing but what? The charge that we are going to bring, this charge. Now we are going to bring Q2. So VB must be equal to W by Q2. That is nothing but work done can be calculated using this formula Q2 into VB. In the beginning itself, I wrote this formula. The work done is nothing but what? Q2 into VB. Correct? So if you use this formula, what it is straight away, you will get it. What is the work done here? In assembling the second charge, work done will be equal to Q2. How many charge you need to bring? Q2 charge. Per charge, how much you need to work? VB. Okay. So total work done is Q2 into VB. So what is VB, ma? VB is KQ1 by R. So together you can write KQ1 Q2 by R. So this is W2. So total work done is W1 plus W2. So 0 plus K Q1 Q2 by R. That is nothing but K Q1 Q2 by R. When you do it in exam, use this formula. Because here you have to write integration and everything. And numerical also you use this formula. Because already we know that electric potential at B is given by what? W by charge, whatever we are going to bring. So W will be equal to number of charges that we are bringing, that is the total amount of charge we are bringing, and multiplied by the potential energy of unit charge. What is potential? It is nothing but potential energy of unit charge. Potential energy per unit charge is nothing but B. What done in bringing a unit positive charge. So unitary method you can calculate. Is it clear or no? Everyone?
Yes, ma'am.
Yeah.
Good. So when you bring two charges, this question is statement you should remember. Okay. When the separation node, you can make it as a node. When the separation between two charges decreases, okay, the electrostatic potential energy what will happen to this? You have to tell me. When the separation between the two charges decreases. So Q1, Q2 separated by a distance R. What is the total potential energy? We know that Q1, Q2 by R. Right?
When the separation decreases, that means R decreases, U value will increase or decrease. And of same polarity. And with sign you need to consider, right? So what it is, if U will be positive, when ma? If Q1 and Q2 are equal and same opposite, same nature, equal and of same polarity. What is the reason? Q1, Q2 product, plus plus plus, minus minus will become plus. So U will be positive in case of same polarity, but U will be negative if Q1 and Q2 are of opposite polarity. Here equal you need not write because it is not necessary, right? All the time it should be equal. Or of opposite polarity. Equal don't write now. Not always all the charges given in the systems are equal. Only same polarity, U will be positive. Negative means it will be of opposite polarity. Now you tell me, as the distance increases, decreases. Okay? If U is positive, then what you said is correct, right? If R decreases, if U is positive, if R decreases, then U will increase or decrease. U will increase. But if U is negative, that time if R decreases, what will happen to the U value, ma? It will decrease or no? Denominator decreases, but U value, negative higher value, minus 50 is lesser than minus 5, right? So that's why U will decrease. So what is your answer? Your answer should be, it may increase or decrease based on the charges involved. Clear? Any doubt?